Welcome to EDU World Space.
So in this question, we are given a 2-inch diameter shaft, right? And this shaft is made from brittle material, right? It is made from brittle material. And this material has an ultimate stress of sigma ultimate, right? Stress of 50 ksi, and for both tension and compression. So we need to determine we need to determine that if the shaft fails, right? That if the shaft fails according to the maximum normal stress theory, right? We need to determine that whether the shaft fails or not, right? And we need to determine it um, considering the maximum normal stress theory, right? So for this, we are going to use a um, factor of safety, factor of safety that is equal to 1.5, right? This is given a piece of information, right? Now let's come towards the solution. The solution is very simple. So the maximum normal stress theory says that the absolute value of sigma sub 1 is equal to uh, ultimate stress, right? And the absolute value of sigma sub 2 is also equal to the ultimate stress, right? So it means that the material, we can say that the material material does not fail to yielding, right? Does not fail to yielding if the principal stresses, right? These principal stresses, they are less than the ultimate stress, right? So now that we have got the criteria out of the way, now let's see what happens with the stresses on the shaft, right? The stresses on the shaft. So we have a positive torque, right? So we have a positive torque, that is counterclockwise, and we have a negative force F, right? That is basically compression. So it means that the force will be responsible for a normal stress, right? This force would be responsible for a normal stress, and that can be found out by using the equation sigma sub x is equal to F divided by A, right? That is equal to negative. Now I'm just plugging in the value. So negative 30 into 10 raised to power 3 divided by pi times 1 square, right? And this is equal to 9.5493 into 10 raised to power 3 psi, right? And this is approximately equal to 9.55 ksi, right? So as you from this value of this normal stress, right? Now if you recall your previous knowledge from chapter number 5, right? It teaches us that torsion creates shear stress, right? And it can be found out by using formula 5.6, right? That is, um, for circular shaft J is equal to pi divided by 2 times r raised to power 4 sub max, right? So it is equal to T times R sub max divided by J. I'm just going to plug in the values, right? So not the values, just these expressions, right? So that is 2 times T divided by pi R cube max, right? So now over here I'm going to plug in the values, right? So let me change the color so that it can be a little bit different from the rest of the working. So it is equal to 2 times 4 times 10 raised to power 3, right? I'm just plugging in the values, the given values that we just the given values and the values that we just calculated. So that is divided by pi times 1 raised to power cube, and that is equal to 3.0588 into 10 raised to power 3 psi, and this is approximately equal to 3.06 ksi, right? So now that we have the value, what we are going to do next is that we are going to find out the principal stresses, right? The principal stresses, and we are going to find out principal stresses by using equation 9.5, right? So first of all, we would solve for for sigma sub 1, that is equal to sigma sub x plus sigma sub y divided by 2 plus under root parenthesis start sigma sub x negative sigma sub y divided by 2 square positive xy square, right? So just plug in the values, right? And you will get that sigma sub 1 is equal to 35.703 into 10 raised to the power 3 psi, right? And that is approximately equal to 35.70 ksi, right? So we have the value for the first principal stress. Now we need to solve it for the second principal stress. So that would be sigma sub x plus sigma sub y divided by 2. Now it's very similar to this equation except that we have a positive over here, and in this case we would have a negative in the middle, right? The rest remains the same. Similarly, we have under root parenthesis sigma sub x negative sigma sub y divided by 2 whole square plus dou sub xy square, right? So just plug in the values and calculate it, and you will get that sigma sub 2 is equal to negative 21.154 into 10 raised to power 3 psi, right? And that is approximately equal to negative 21.5 ksi, right? 21.15 ksi. Now finally we have all the information that we need, right? So what we need to do over here is that all we need to do is just compare the magnitude of these two stresses to find out which one is the bigger one. And it is clear that the bigger one is sigma sub 1, right? This is the bigger one. So the yield stress would be the absolute value of sigma sub 1, right? And that is 35.70 ksi. So now all we have to do is to check that if the safety factor of the safety Safety factor is at least 1.5, right? So let's call it K over here. Let me change the color to differentiate it. So K is equal to sigma sub y sub material divided by sigma sub y. We have the values 50 divided by 35.7. So that is equal to 1.4, right? And that is less than 1.5. That was the given value of the safety factor, right? So it means that the test does not pass, and therefore the material yields. And this concludes our answer, right? So this is your solution.